We'll be going over the power rule, and the power rule is essentially going to be like your best friend. It's going to be the most common rule you're going to be used for calculating derivatives, and you're going to have to use it all the time. Every single derivative problem is going to have you entail some form of the product of the power rule, so it's important. So as we learned earlier, we use this equation to calculate the derivative. So the limit as h approaches 0 of f of x plus h minus f of x divided by h, and we use this to calculate the derivative of a function. However, this way tends to be pretty tedious and is often, for larger equations, can become quite messy. So for the power rule, it's really easy. You could do it in your head. So here are just for examples, and hopefully you can kind of see the pattern. So f of x is equal to negative 5x plus 3. I know the derivative of this is going to be equal to negative 5. Now let's say I have f of x is equal to 2x squared minus 1. I know f prime of x is going to be equal to 4x. Or let's say I have f of x, is equal to x squared plus 2x minus 4. I know that f prime of x is going to equal 2x plus 2. And then for the last one, let's just say f of x is equal to 3x squared plus 2x and like minus 2. I know f prime of x is going to be equal to 6x plus 2. Now, hopefully you guys can see the pattern here. But essentially what I'm doing is taking the exponent on the x variable, multiplying it by the number in front, and subtracting 1. So in order to write that out, if you have f of x is equal to, and let's just say c is just some number times x to the n, f prime of x is going to be equal to n times c times x to n minus 1. And so that's your equation, and this is going to be the rule you're going to be using the most often. So here's an example where you can really see it. So let's just say we have 3x squared plus 2x minus 2. So essentially what I'm doing is I'm taking the exponent, multiplying it by the number in front. So in this case, we'll be left with 6 and then x, and then subtracting 1 from the exponent. So the exponent in this case is 2. 2 minus 1 is just 1. X and 1 is just x. So I can write it as like just 6x. And in this case, we have 2x, so the derivative of that, x is equal to x to the 1. So you can imagine a 1 right there. And we take 1 times 2, so we're just left with 2. And then minus 1 is just 0. And x to the 0 is just equal to 1. So 1 times 2 is just 2. So that's all there is to it. Now in this case with the negative 2, we can imagine an x to the 0 right here, because x to the 0 is equal to 1. So 0 times 2 is just 0, and that's like, it makes no sense. So in this case, it would just essentially be minus 0. So we're left with the derivative of this equation is going to be equal to 6x plus 2. Now, hopefully that makes sense. It's relatively easy, and yeah. And when I'm talking about this rule, I'm also taking into consideration another rule called the sum and difference rule. This rule is kind of intuitive and pretty obvious, but it's important to like go over. So if you want to take the derivative with respect to x of some function f of x plus another function g of x, then it's going to equal f prime of x, or the derivative of f of x plus the derivative of g of x. And remember, these primes just mean the derivative. So let's just say in this case, let's just say y is equal to 3x squared plus 2x minus 2. I could just say f of x is equal to 3x squared, g of x equal to 2 of x, and let's just say this is another function. We'll just call this one h of x is equal to negative 2. So if we do find a derivative of this one, we know f prime of x is just going to be equal to 6x according to this power rule. g prime of x just going to be equal to 2, and then h prime of x is just going to be equal to 0. So then we just get our derivative of just 6x plus 2. And so you can also, this is a plus sign right here. However, it can also be a minus sign, so plus or minus. And so it's kind of obvious, but that's just important to go over just to make sure. And so as you can see, this rule is pretty basic. So let's go over an example. Let's just say an example is we want f prime of x of f of x equals 4x squared plus 2x, and then let's just say plus 2. So we f prime of x is going to be equal to this one. So we can actually, I can write it out. So this would be equal to 2, because exponent in this case is 2 times 4 to the x, 2 minus 1. And then in this case, this will be equal to 1 times 2 to the x. And then remember, there's just a 1 up here. So 1 minus 1. And in this case, for the 2, it's just going to be, this is 2 is also equal to 2x to the 0. So we can just imagine 0 times 2x to the 0 minus 1. And this is just all going to equal 0. So we can say the derivative of this is just going to be equal to 2 times 4 is 8. So 8x, 2 minus 1 is just 1. X to the 1 is the same thing as just writing x. So we can just write x. 8x plus, in this case, 1 times 2 is just 2. And then x to the 1 minus 1 is just 0. And x to the 0 is just 1. So this is it. It's just 8x plus 2. Now we can go over an even more even though it may appear more complicated, it's actually just the same thing. So let's just say we want f of x equals 2x to the negative third plus x squared over 2 plus 2 times the square root of x. Now, it may seem like you can't really do this rule right here. However, you can. It just simply requires you to rewrite it a little bit. So we could just say f of x is equal to 2x in the minus third is fine. So we can just leave this as 2x in the minus third plus x squared divided by 2 is the same thing as 1/2 x squared plus 2 times the square root of x. We know the square root of x is equal to x to the 1/2. So this is just equal to 2x to the 1/2. And you could do this rule with any exponent. It doesn't matter. It could be a fraction and so on. So we can figure out the derivative of this. So f prime of x. So the exponent times that, so will be equal to -3 times 2, -3 minus 1, plus, and then 2 times 1/2 x 2 minus 1, plus 1/2 times 2 x to the 1/2 minus 1. So when we solve this and simplify, -3 times 2 is -6, and then -3 minus 1 is just -4. So this becomes -6x to the -4 plus, and then 2 times 1/2 is just 1. So then we're just left with x to the 2 minus 1. 2 minus 1 is just 1, so this is just x. And then for this one, 1/2 times 2 again is just 1. And so x to the 1/2 minus 1 is -1/2. So this is just x to the -1/2. However, we can further simplify this and put this in its proper form. So as you know, if you have a negative exponent, you can move that to the denominator to make it positive. So this just becomes -6 over x to the 4th plus x plus, and this one, x to the 1/2, -1/2 can again be put on the denominator. So this just becomes square root of 1 over x. And there you go. So this is going to be the most common rule, so make sure you know it, and it's relatively easy, and I hope this video makes sense.